Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 8, which is all about exponentials, and today we're talking about logarithmic functions. This is 8.4, Day 1. Our essential questions on this worksheet are, how do we go back and forth between logarithmic form and exponential form? Are we able to evaluate logarithms without a calculator? And are we able to simplify logarithms? So, a logarithmic function is the inverse, the inverse of an exponential function. So for example, let's do an easy way to describe this here. So if we have log base a of b equals x, the way this works is it's the same thing as saying we push this a over here, we push up the x a little bit, and we're going to get a to the x equals b. So basically, instead of a to what number equals b, it's saying, well, that's what it's saying basically, right? So it's log base a of b, it's saying what number to the x power equals b. What number to the x power equals what this b is right here, okay? And that's kind of what it's saying. All right, so we have our first example, says what value of x is a solution to 3 to what power equals 30? Well, we know like the perfect cubes and perfect fourths and all that stuff. We know, we're going to kind of have to think this through a little bit. We know 3 to the third equals 27, and what's 3 to the fourth? We're just trying to get a baseline to figure out what, like, kind of where we're at here, okay? So 3 to the fourth is 81, okay? So we know that it's not 3 to the third and 3 to the fourth. It looks like it's going to be 27 is closer to 30 than 81 is, though, okay? So we're going to guess a couple things here. So we're going to kind of try some numbers in our calculator to see what we can come up with here, okay? So let's guess that 3 to the power of, instead of, so 30 is a little bit above 27, so let's go to 3 to the 3.1 and see what we get. What's that approximately equal to? Well, that's approximately equal to 30.13. Okay, so we're getting closer. We're getting closer to 30. Now let's try 3 to the, so we got to go a little bit lower though. So let's try 3 to the 3.01 and see what we get on our calculator. And for that, we should get about 27.29. So we were actually closer when we did 3 to the 3.1. So let's try something a little bit lower than 3.1, but not too far off. So let's try 3 to the 3.096. I'm just going to try a little bit lower than 3.1 because we're only a little bit off. And that's going to be approximately 30, okay? So this is kind of how you can like using a calculator and kind of figure out an approximation here. So we're going to write log base 3 of 30 is going to be approximately equal to 3.096. Okay? So that's what that kind of means. All right, so we can kind of guess and check. We can figure out what the big perfects are right here with the 3 to the third and 3 to the fourth, and we can kind of move up and down, above 3 or below 3 or above 4 or below 4, and kind of figure out what's kind of close to that and kind of guess that way, okay? So what's the basic definition of a logarithm? And say logarithm. Say logarithm. Okay, a logarithm. It's kind of a fun word. A logarithm is an exponent. A logarithm is an exponent. Okay? All right. Okay, so what's the definition of a logarithm with base b? So we have let b and y be positive numbers. B does not equal 1. This is all kind of complex stuff here. We're going to go back to what we were kind of talking about before. We're going to use a little bit different values here, but log base b of y equals x if and only if, that's what this means here, if and only if, and like I said, you take this b, you're going to push up the x a little bit into the exponent, and you're going to get b to the x equals y. Okay? So this is read as log, the way you read this is log base b of y is x. That's how you read that, okay? That's how you read this right here. Log base b of y is x, or is equal to x. Okay, let's move along here. So we have log base 3 of 9 equals 2 because we take the 3, we push up the 2, we're going to get 3 squared equals 9. This should be true. and it's the same base in both. Okay, sounds good. Moving on, it says rewrite the equation in the other forms. We have logarithmic form and we have exponential form. So we have log base 4 of 64 equals 3. So again, the way that you change this is you're going to do 4 to the third power. You're going to push it up. 4 to the third power equals 64. That's exponential form. Okay, why don't you see if you can try the other ones on your own, see how you do. All right, sounds good. Now for this one, we're giving it an exponential form. We're going the opposite direction. So in this case, it's like we took the 6 when we pushed up the 0 already. So the way you would write this is a little bit tricky. It's going the opposite direction. Now we're not pushing up the with the 6. We're actually going to bring the 6 back. We're going to bring the 6 back here in the base. So it's going to be log base 6 of 1 is going to equal 0. Then the 0 kind of pushes back down. I should actually erase that. Eraser. I can't erase it for some reason. Oh well. All right. Yes, it's log base 6 of 1 equals 0, basically. All right. Okay, then we have log base 1/3 of 81 equals -4. So we're going to take this 1/3. We're going to push it up. So we're going to have parentheses 1/3 to the -4th equals 81. And remember, negative exponents with fractions basically flip the fraction, okay? So it's basically 1/3 to the -4th is the same thing as 3 to the 4th. All right? All right, we got one more here. We have 8 to the 2/3 equals 4. So 2/3 is going to be kind of by itself. This is going to drop down, and this 8 is going to move back over here. So we're going to go like this. We're going to have log base 8 of 4 equals 2/3. And that's how you write something going back and forth between logarithmic form and exponential form. Okay? Alrighty. All right, special logarithmic values. Special logarithmic values. Let b be a positive number such that b is not equal to 1. So if we have log base b of 1 equals 0, that's because if we switch this to exponential form, it's going to be b to the 0. Well, what's anything to the 0 power? That's going to be equal to 1. That's why log base 1 of 0, log base b of 1 equals 0. And a similar thing, we have log base b of b equals 1 because b to the first power is going to equal, push this over here, push it up, b to the first power is going to equal b. Okay? So what log is saying? It's saying what number, it's saying b to what number or what value equals b. B to what number equals b. In this case, it's b to the first power. Over here, it's saying 4 to what power equals 64 is what the log is saying. It's saying 6 to what power equals 1. Okay, that's what log basically means. All right, evaluate the expression without a calculator. All right, so what we're going to do for this is we are going to set equal to 0 and ask what power gives you y. Okay, we're going to say set it equal to 0 and ask what power gives you y. So let's do it here. So we're going to set it equal to y. We're going to take the 5. We're going to push it up the y here. So we're going to have 5 to the y power equals 125, right? Okay, well, what number, 5 to what number equals 125? In this case, it's 5 to the 3rd, right? Because that's the cube root of 125. So our y value here, the log of this is going to equal 3. And there's our answer. Okay. Let's see if you can try the other couple on your own. See how you do. All right. We have log base 32 of 2 equals what number? So we're going to take 32. We're going to push up the y. So we have 32 to what value equals 2? Well, in this case, we got to be a little tricky about this. So what's the relationship between 32 and 2? Well, 2 to the 5th power equals 32. So in this case, we have to do something a little bit tricky. This is actually going to be 32 to the 1/5 power, right? The 5th root of 32 equals 2. So in this case, y is going to equal 1/5. Okay? So sometimes it's going to be, if it's a fraction exponent, it's going to be like a root. And if it's a whole number, it's going to be an exponent. All right, sounds good. Log base 2 of what equals 0.25? So we're going to take 2 to what number? 2 to what number equals 0.25. I'm actually going to, what's another way to write 0.25 as a fraction? What's 0.25 as a fraction? It's 1/4. Ooh, this is a little tricky. So how do we get 1/4 from 2? 2 to what power equals 1/4? Well, it's a 2 squared equals 4, so that's kind of close. How do we make it 1/4? Well, we make it a negative exponent, right? So it's going to be 2 to the negative second is going to equal 1/4. So in this case, y is going to equal -2. All right. So if you have a fraction that's kind of the reverse or the inverse of what you're looking for, all you got to do is make it a negative exponent or make it a positive exponent if it's already a negative. Okay, and that's going to flip it. All right, last one we have saying what 1/4 to what number equals 256. We're going to take the 1/4. We're going to push up the y. So we got 1/4 to the y equals 256. So in this case, 256 is a nice whole number, and so we're going to need a negative exponent probably for this one. So so what I like to look at here is the 4. 4 to what number is 256? Well, 4 to the 4th equals 256. So I'm going to do 1/4 to the -4 because that's going to flip this fraction. It's going to flip it to 4 to the 4th, which is going to be 256. So we get, so our y value is going to be y equals -4. Okay, so some heavy-duty exponential stuff, but hopefully that makes good sense. All right, moving on. Here we go. So different types of logarithms. We have common logarithms, and we have natural logarithms, and then we have regular, it all depends on what kind of base we have here, okay? So a common logarithm, most of the numbers that you work with have a base of 10. Most of the things we work with are a base of 10, but a natural logarithm, which is ln on your calculator, it's going to have a base of e. It's going to be e, like log base, yeah, so let's go ahead and do this here. So common logarithm is going to be log base 10 of x is going to equal log of x. So whenever you see just log on your calculator, it's automatically base 10. It's saying 10 to what power equals that value of x. If you have a natural logarithm, that's going to be log base e. Oops, that's not base. Log base e of x, and that's going to equal, we would write that as ln of x. This is natural log. Okay, so natural log is important, and it's base e. And, sorry, I dropped my water bottle. And regular log is going to be base 10. Okay, so it says evaluate with a calculator to 3 decimal places. Okay, so why don't you go ahead and see if you can figure these out. You're just going to plug them into your calculator. So first thing I'm going to give a hint on log of 85, that's automatically just base 10. See if you can give these a try, and we'll go through the answers in a second. All right, log base 10 of 85, or just regular log, is 1.929. Number 2, log of 1,134 is 3.055. And then we have natural log of 0.25 is going to be negative 1.386. And then natural log of 7.25 is 1.981. So what this is saying, it's saying, just to kind of review here, so like for example, natural log, it's saying e to what value, if we put equal to y here actually, it's equal to y, it's saying e to what value equals 7.25. So that's saying basically take 2.718 to what number equals 7.25. It's basically telling you what the power is that would give you 7.25 when you multiply it, okay? All right, and there we go. We got one more thing to talk about here, special properties of logarithms. So since logarithmic functions and exponential functions are inverses, then remember when we do inverse functions, if you do f of g of x and g of f of x, you do, you compose, you plug in the function into the other function, basically. You do composition of a function, you're going to get it's equal to x, okay? So for example, if we have f of x equals b of x, which is an exponent, and then log base b of x is g of x, then it's going to be b, in this case, b to the log base b of x is going to equal x. And down here, this is going to be the same thing. If you do the opposite, it's going to be log base b of b to the x equals x. Okay, so in this top equation, we plugged in g. We plugged in g into f, into this x value right here. And then in the g of x, we plugged in this into right here. Okay? That's kind of what happened here. All right, so let's go ahead and do these problems together. So we have 5 to the log base 5 of x. All right. Well, 5 to the power of a log, those are going to cancel out if they're the same base. 5 to the log base 5 of x. This one is just going to equal x. Ta-da! We know that it's an inverse then, okay? Let's do the second one now. Log base 17 of 17 to the x. So we have a base and an exponent to 17. So this is actually also going to equal x, which is great. So, yeah. So this is saying 17 to what power equals 17 to the x. This is what this is saying, right? If we do this equals what? We take this, we push up this exponent here. Well, what does y have to equal for it to be 17 to the x? Well, this has to equal 17 to the x for it to equal 17 to the x. Okay, that's kind of what's happening here. If that helps makes more sense. Same thing over here. This is saying 5 to the what equals, 5 to the, so let's see here. So yeah, so basically what I'm trying to say here is that an exponent to a log is, they're basically, it's kind of like the same thing as if we do x squared to the 1/2 or the square root of x squared. It's basically going to cancel out the square root here. So that's why they kind of cancel out, okay? We'll talk about the last example now. We have log base 5 of 25 to the x. Of 25 to the x. So in this case, they're not actually going to cancel out perfectly because what is 25? Well, if we rewrite this, we're going to have log base 5 of 25 is the same thing as 5 squared all to the x. So this is not exactly what we're looking for here because another way to rewrite this, if we wanted to cancel out the log and the exponent, it's going to be log base 5 of, well, 5 squared, I can rewrite that as 5 to the 2x, right? Because this is a pow-pow thing happening right here. And so these are going to cancel. The log base 5 and the 5 are going to cancel, but this equals 2x. So in this case, this is not going to be, these are not, this is not inverses of each other because you get 2x instead of 1x, okay? All right, that should be all I have for you today. Thank you for watching. Have a great day, and we will talk soon.